Hello everyone. For this tutorial video I'd like to talk about parametric surfaces, or surfaces given by parametric equations, as well as give a revisit/recap to how parametric equations of lines or vectors worked. We remember that when we expressed a vector in terms of a parameter, it became x as a function of t times the x component plus y as a function of t times the y component, and so on. This logic and formula actually holds true for surfaces as well, but we will see that surfaces have two inputs, whereas vectors only have one parameter. And the convention is to express it as u comma v, because of how u and v are alphabetically after t. So we do u and v to distinguish how they are two different types of parameters than the single parameter t. So if we are given a specific parametric equation like this, we would first express x, y, and z equal to the components, and we can see with some trickery we can use the trig identity using the Pythagorean theorem by doing y squared plus z squared, and this turns into u squared after we simplify our work. And we also see, because we defined x as exactly equal to u, this means we can substitute in x squared. So we conclude that x squared equals y squared plus z squared. So we get a formula for a cone, except it opens around a different axis, in particular the x-axis rather than the z-axis. So now that we know what parametric surfaces are, we can talk about basic rules and computations related to surface integrals in the next video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.